Nothing else? 19? You got it. Let's take a look. (10u to the 3 halves minus 14u to the 5 halves). du. So this would be expressed as 10 integrals of u to the 3 halves du minus 14 antiderivatives. Antiderivative and indefinite integral mean the same thing. U to the 5 halves du. So I want to increase these exponents by 1, so this becomes 5 halves. U to the 5 halves, oops, not 52. And that's 10 of them, and then divide by 5 halves, so that would be times 2 over 5, minus 14 u to the 5 halves, so that would become 7 halves, u to the 7 halves, divide by 7 halves, this would be times 2 over 7. So here we get 25ths, that would be 4 u to the 5 halves, minus 14 sevenths is 2 times 2 is 4 u to the 7 halves, and don't forget the plus c. Is that good, Avery? Sweet. Anything else, y'all? Cool. Let's take a look. So, doing more of the same today. The velocity is, where'd it go? 6t squared minus 8t. This is the velocity at time t. Object is at 5 when the time is 0. Position 5 when t equals 0 seconds. Do we not have units? The book doesn't declare units. It's ridiculous. So position 5 units. Dumb book. Okay, so in the past we started with position, and we can differentiate to get to velocity and acceleration, and jerk and jounce and snap, crackle, pop, right? We talked about that. Now we have the velocity, and we're asking for the position function. I didn't even write that, so that's the goal here. So find the position function. In other words, like, anytime you're given like an acceleration, velocity, position problem, just think about a car. This is some kind of function telling you what speed you're going at every point in time. So if you know everything about the speed that you've been going, then you should be able to infer the distance, right? No problem. And that's why this is crucial. That'll tell us exactly what's going on. So we want to anti-differentiate v to get to distance. So, in other words, let's see. We can do distance, velocity, acceleration. Is how you spell it? Yeah, that is how you spell it. Okay, cool. So distance, you differentiate once, you get velocity, and you differentiate another time, you get acceleration. So these are derivatives. Acceleration, you antiderive once, you get velocity, and you antiderive twice, or if you just antiderive velocity, you get distance. So it's like going down or up the ladder, if that makes sense. Right. This is in units of just distance, distance per second, and distance per second. Right. Each rung on the ladder is a different resolution in terms of dimensions of seconds. Whether it's not seconds at all, velocity is per second, and acceleration is per second per second. Okay, so we've got this, and we want to anti-differentiate. Okay, no problem. We've done a ton of these already. So 6t squared minus 8t dt. So we get 6 integrals t squared dt minus 8 integrals t dt. Increase the t squared, and it becomes t cubed divided by 3. So 6t cubed divided by 3 minus 8t squared divided by 2. So the exponent is currently 1, it goes to a 2, and you divide by 2. And of course, don't forget the plus c. So 6/3 is 2t cubed minus 4t squared plus c. So this is our distance function. Okay, well, that's a problem, right? What is c? We don't really know what c is, but there's another piece of information we haven't used yet, and it's that the position is 5 units when t equals 0 seconds. In other words, d of 0 equals 5. That's the information we just got from up there. So if I plug in 0, I better get 5. So when I plug in 0, these both go away. 2 times 0 cubed is 0, minus 4 times 0 squared is 0. So literally c equals 5. Okay, so then d of t must be 2 cubed minus 4t squared plus 5. So in other words, imagine if we weren't given the distance at time 0. So then we're talking about this distance function because we knew the velocity, but we don't know where it started. So we know how the distance has changed and everything, and if we knew anything about the distance, we could tell you about it. But this is showing that we haven't really dictated anything about the distance yet. But as soon as we have that piece of information, we're able to tell what c is. Any questions about this? Then let's see. It might even ask you what is the distance, and the book will sometimes say position, and it might give s of t. So these are the same thing. What is the distance at t equals 10 seconds? Well, we literally have a function right here, so that's not too bad. Just plug in t. So d of 10 equals 2 times 10 cubed minus 4 times 10 squared plus 5. 10 cubed is 1,000, so it's 2,000 minus 400 plus 5. I get 1605 units. Let's take a look. Alright, I'm going to give y'all one to try. So let's see. So please find s of t or d of t. These are interchangeable. The position function, right? And also, please find the position at t equals 2 seconds. Hopefully that's not too small. I'm just trying to show you the example problem so you can operate off of that as well. Also, happy Friday. You've earned it, that's for sure. I'll also ask y'all what I asked my other class. What is the most delicious food you have had in the past few days? Pizza. It's a good idea. Might have to have pizza tonight. Cold beans with soy milk. Molten lava cake. That sounds amazing. Wow, nice, Avery. Is it like box or from scratch? Very cool. Yeah, making cake from scratch is crazy difficult. Take out sushi. I love sushi. I just raw fish puts me off. I can eat like cooked or vegetarian sushi though, for sure. Is anybody still working? Peanut butter chocolate cake. Goodness, that sounds incredible. All right. I'm gonna assume nobody is still working. So let's take a gander. 15t squared minus 11t, so we want to antiderive. So this would be t cubed divided by 3 times 15 minus 11 halves t squared plus c. And furthermore, the stipulation was position at t equals 0 is 13 units. This is our position function. S of 0 is 13. So this becomes 5, right? No big deal. So that, these literally go away. So c equals 13. So our full position function is S of t equals 5t cubed minus 11 halves t squared plus 13. That's what we just found, and we want to find S of 2. So S of 2 would be 5 times 2 cubed, that's 5 times 8, minus 11 halves times 4 plus 13. It's 40 plus 22, so 60. 40 minus 22, so that's 18 plus 13 is 41. Right? No, 31. 18 plus 13 is 31. So S of 2 is 31 units. Let me check my arithmetic there again. 40 minus 22, 18 plus 13, yeah, 31. I think I'm still half asleep, y'all. Any questions with this? Are we pretty comfortable with this? Not too bad, right? Make a new. Let's take another look at another problem. F prime of x equals 6x squared plus 4. Point 1, 1. That's boring. It's really boring, I guess. Alright. So, we are given the slope. I mean, what unit are we in? It's antiderivatives, right? So we just need to differentiate. And if you anti-differentiate slope, you're going to get just the original function. So we want, let's see. Um, 6x squared plus 4 dx. So you get x cubed over 3 times 6 plus 4x plus c. And that is our antiderivative. And then we know that f of 1 equals 1. Whoops. F of 1 equals 1. And so f of 1, I'm just going to go ahead and plug in 1. 6 times 1 cubed over 3 is just 2. Whoops. So maybe I'll just simplify this. That's 2. 2 times 1 cubed is 2 plus 4 plus c. So 6 plus c equals 1. So c must be negative 5. So our true function is x cubed plus 4x minus 5. So I actually want to show you something here with Desmos. Let me pull it up. Okay, so y'all can see that. Give me just 1 second here. Perfect. Okay. So, we are talking about some... Let's see. Some function whose slope is 6x squared plus 4. So, and we found that f of x equals, what was it? I'm gonna do the one before we input the position. So that's x cubed plus 4x plus c. We've talked before, this c is just vertical shift. It doesn't look like vertical shift, but it is. That's kind of crazy. The nature of this curve, it looks like it's going left and right as c changes, but it's just vertical shift. Because notice, yeah, that's nuts. That's almost like an optical illusion. Yeah, it's a little easier to see there that it's just a vertical shift. So now watch. That's what we determined, and so f prime of x, wait, did I do something wrong? Let's see. Oh, it should be 2. There we go. So, this was the derivative from earlier. So, I guess we can do this in black. So look, as I change c, the derivative doesn't change, right? The vertical position of the graph doesn't change the slope at all. But as soon as I stipulate that f of 1 equals 1, then it's like, okay, we need to find the graph that actually goes through that point. And look, I wasn't even watching, but c equals -5 led us there. If c is anything else, the graph doesn't go through the point, right? So the derivative to begin with allows us to find the curve. But we don't know what the vertical position of the curve is. But when we get some point on the curve, we are able to fit the curve to the point. Hopefully this makes sense. I think I did alright explaining. Okay, so let's see. I will give y'all one to try here. So let's see. So 1/2 plus 4. Passes through 1 comma -2. So please find this function. Oh, I never switched to. Okay, you probably would like to see that. Okay, so here it is. Please find this function. And I left the example problem above so you can follow that. Anybody still working? Have we finished? You don't know until you try it, I suppose. Alright, let's anti-differentiate. So 1/2 becomes a 3/2. Divide by 3/2. This is the 3 from earlier, and this is the dividing by 3/2 plus 4x. If it's a constant, it just becomes that. So no problem, plus c. This is our function. And so that would be 6/3 is 2x to the 3/2 plus 4x plus c. And furthermore, f of 1 equals -2. So f of 1, I'm going to plug in 1. So I get 2 times 1 is 2 plus 4 plus c equals -2. So I get 6 plus c equals -2. C equals -8. He's just trying to do his best job, Blake. Rest in peace. Yeah, big F. So, I'll write our function here in cyan. So, the final function we get, f of x equals 2x to the 3/2 plus 4x minus 8. Any questions about this? Alright, let's conclude there. And I told you that I would give you some problems to look at so you'd be ready for the quiz. So if you look at 6.2, 9, 11, 14, 21, the one optimization problem that I put on the quiz will be pretty much like one of these, pretty much exactly like one of those. So if you know these 4 problems, you're good. And then also on the quiz is stuff from like last night's homework. So anything like this. Anything along these lines is fair game. So, and then tonight's homework is page 366. It's the same page. 43 and 44. Um, 65. 67 and 68. And I'll send pictures. Cool. Okay, if y'all need anything, let me know, and have an incredible weekend. Peace, y'all.